We're working with AAM to update the secret chamber attraction deep down here underneath Sovereign Hill. Sovereign Hill is an open-air museum in the heart of Ballarat. The secret chamber attraction is around 18 years old, so it was in need of a much-needed update. And in order to bring it into the 21st century, we wanted to make sure we were using the latest in presentation technology. But that also meant that we had to have the latest and the best in scanning technology for us to have a really amazing canvas to work from. That's when we approached AAM and their HDS, or High Definition Survey, laser scanning to come on board. And frankly, the results that we've been getting are just unlike anything that even we were expecting. We're able to get pixel to pixel resolution from the scans that the guys are doing. So when we project back onto this existing rock wall that's behind us, we're going to be able to get into every nook and cranny that you see in a genuine 3D space. It has the other benefit of giving us more than as-built CAD plans. We actually have this space in a one-to-one scale resolution that we're able to do a whole myriad of things, from lighting to doing updated plans, and then of course the production of the show itself. We're delighted to be working with AAM on this unique experience. It's a one of a kind, not just for Australia but anywhere in the world, and I couldn't think of a better partner to have on our team.
No cash for comments there, but certainly whether it's a mine site or whether it's an as-built or 18 floors up like our recent project, I'll just plug my power in because I know that's probably not going to last the distance. The importance of understanding the exact space you're in, the dimensions, the qualities of it, any of the existing services, any of the existing assets that are there, extremely important. And up until now, most of the way it's been done is fairly rudimentary. Whether it's, in my case, from an architecture background, it's usually the architecture student with a pen and paper and an old tape measure, a disto if you're lucky. That seemed like an incredibly poor way of ensuring any of sort of hope of getting any sort of lean construction methodology if you're starting off already on the back foot with that sort of approach to capturing. Certainly in the services world, I know there's a lot more, has been a lot more technical than that, which is great. And certainly from the services world, I know that a lot of the people, Craig Kennedy and others, have been looking at reality capture and point scanning in particular to help with as-builts or as-is or as-should-bes, and rectification or innovation and rejuvenation, which we'll show in some of the live demos if I can be brave enough. But for most of you have probably seen or heard what it can do, and the equipment, several vendors are here today showing that it's not that much of an impost to bring it on site the same way you would do a normal total station or even a jigger. But the ability to capture all of the scene quite quickly, very high resolution, and now with the support of a lot of the vendors, Bentley have an import tool to POD format, and Autodesk have been supporting various formats, and now with their recap technology have a fairly good base flow, I guess, workflow to bring this into everyday CAD/BIM work, and certainly the results we've got is very impressive. So a little bit about AAM. It's now a group of surveying companies, and for those of you who might have remembered Vector, HDS is the team that came across to AAM. That's where I'm involved with their scan for BIM and scanning and BIM deliverables. Also, however, do a lot of the traditional surveying, do a lot of aerial acquisition, LiDAR work, a lot of monitoring and sensor work as well. I guess the normal way of presenting what scanning can do is in either a point cloud form, which is generally the hypercolor dealing with intensity values. Some of the latest technology can have color mapping to those pixels, so you start to get an almost realistic view. Some deliverables, depending on the modeling package. We use Revit. We also use Rhino and a few others for some meshes and some other landforms and geometry requirements. And fairly easily acquired. The trick, of course, is making sure that it's survey grade, not just survey accurate. So it comes back to control points, to control systems within the construction site, or precinct modelling, and understanding how to work across various packages and various deliverables. So that's the kit. Some of these are extremely expensive, but they're extremely hyper accurate and very, very good. And there are ones in the middle, and the range of those depending on the task at hand. We are co-sponsored and using Leica hardware. There's a few others, but certainly Leica I think have the highest quality and the biggest range, which is fun to play with. So everyone's got a cycle, and acknowledgements to Dominic for his cycle of death. Ours isn't quite that drastic, but certainly you can involve a surveyor in particular, but a HDS or a high definition scanning surveyor at all cycles, all parts of the wheel. We find that we're involved at brownfield or greenfield sites, and even with HDS on those levels, it can play quite an important role. Through to construction management and construction control, implementation, of course, making sure everything's going on site as it was supposed to be, and more importantly, and where we've been asked to get involved the most, is rejuvenation at the moment. A lot of buildings stock in Melbourne, especially, is just on 30 years, no longer meeting specs for Green Star and energy efficiency, and majority of those plans have gone by the wayside. So we're going in almost to an undocumented precinct, and recreating documentation for then the services engineer in this case to work from. And we'll show a couple of examples of that. Again, apologies for the filming crew, but I need to plug into the internet at some point as well. I'll do that just before the end. So a little bit of background on some of the projects we've been working on. Darling Harbour is going through a massive regen. We've point cloud scanned the majority of that area. One of the things about working in a precinct like that is there's a high traffic flow. No one wants to shut down roads. HDS can work in and around and under roads and over and be quite discreet in its acquisition. And so those clouds have been stitched together, controlled and supplied to all the various parties that are involved in that construction project. So we become, I guess, like the surveyor of truth, the provider of truth to all the independent parties. And that's working quite well. We provide some base modelling in that particular project, and again, levels and access to sites and construction methodologies all determined by what we've provided back. And in this case, we've provided back as a LOD, say 200 or so, base model for the architects to work with. The acquisition of that can be quite quick in real terms compared to traditional surveying methods. And of course, we end up scanning everything almost, and invariably that's what the people are after, because they wouldn't have asked us to do it that way to begin with, i.e., did you actually happen to get the undersoffit of that overpass? And yes, we did. So the benefit of HDS is that you've captured almost everything, and invariably you'll need everything at some point anyway. So less mobilisation, going back to site and resurveying areas. We were involved for construction control on Dexus. That wasn't a HDS job, but certainly from our normal sort of construction surveying teams involved with that. We're also doing construction control on the Chow Chak Wing, I should get that right. Yeah, you can imagine and certainly the construction control on the brickwork has been quite amazing. So the live case study, this is where everyone holds their breath. Certainly, we're dealing with large data sets. There's no way getting around the fact that HDS provide terabytes of information in some cases. It's how to I guess, pick the right bits. It's how to control it. It's how to work in various formats to make sure the architects, who in this case hadn't used Revit for a fit-out job like this before. So this was the interior design team at Hassel. And so by us providing that as a base BIM model, I've said the word, they were able to hit the ground running. In some cases, we are providing IFCs as well. We've got some clients in the room who aren't using Revit for a particular job. We've had to go in and do an acquisition of their project area and actually align their model back to truth. So over the years and various iterations and gestation periods of a project, the model's got a bit out of whack. And so now that they've got a go-ahead, we've actually aligned their model back to reality. So it's, again, something that can be done to give confidence back to the modelling team. So in that note, I'll just show you basically how it works in practice. So this is 8 Nicholson Street, building the top end of Spring Street, just on the back of the Bates Smart Orica building. And this is, just by happenstance, I guess, the precinct that we've covered. Obviously, the area of interest is the building in the middle, but we do actually happen to pick up, just by the nature of the way we acquire, lots of other things. So as far as context and precinct, it's a good way of understanding what's going on. Now you'll see in the background there that the actual building has been modelled as well. What we were able to get access to middle way through the project is a lot of the original documentation, and some of the people in the room might remember the firm of Meldrum, Burrows and Partners. Really nice documentation, just happens to be hand-drawn and very PDF TIFF. So I brought that in to understand grid allocations and naming conventions and just a general understanding how the building was supposed to go together. In a lot of cases it was like that. And that gave us some confidence to suggest some additional things back to the architect, which we wouldn't normally be able to provide in a HDS world. Although the presentations look very hyperreal and X-ray-like, we only can scan what we see, so we don't normally get inside column casings, we don't normally get inside roof soffits unless people ask us to. But in this case, because we had the original architecturals, we can allocate or indicate what was supposed to be there on which grids, and then we give an indication of what was there in the reality. So if we zoom down here to, the screen is a bit small. So this ends up being what we've provided back to the mechanical engineers on this job as well as the architect. If you're a bit amazed that we did the furniture, so were we, but this is a demounting and a mobilisation task for Hassel just as much as it is a redesign, so they have to understand how many people are there in the space, how many people have to move between floors. So we ended up modelling in generic models, but real bums on seat count, so they can understand how they're going to move between floors and what staging to do. And the only bits we didn't have to do, because they're not altering those, is escape stairs or vertical transportation. You'll see as we sort of zoom around to the edge here that in this case our mechanical engineering partners, ARAP, who are presenting after this, then took our point cloud from that datum point up, so level 18, and regenerated or turned into BIM, I guess is one crude way of saying it, all the existing services, as well as all the staging for the regen and the refit as that moved through the building cycle as well. We provided the base BIM, progressive BIM as we move the, I guess, more detailed into the project, and now the architect's working on this. The architect also wanted the point clouds, which is fine. I'm not exactly sure how much they're using it into informing what they're doing, because the model is pretty well complete. But I can certainly see a situation where you may actually just request from us or services like us the point cloud if you were, say like ARAP, able to handle it and able to use it, certainly as a background reference. That's not exactly what I wanted, so I'm just going to reorientate this to floor plan 15, which hopefully has the point cloud live, or linked at least. And this is a typical floor plate that is then achieved, again, for space planning, for even communication back to, in this case, the client, who's very supportive of this. So Dexus, in this case, commissioned us to do this work and provide the various geographical spatial information, I should probably say, back to the various parties. And as the project continues on, we'll be providing that data as a single point of truth as well. I think I might have turned the point cloud off. Yes, I did. So the fact that its point clouds are supported in Revit is extremely handy. Obviously, they could... Excellent. That's not quite the right resolution. Any hints on that? Trick for beginners, when you squash your screen, invariably... Let's pretend that was turned on. But it sits in there anyway. I can't quite get to the select button. And certainly I could see that, you know, as this process becomes even easier, that's the way that you will engage with your spatial provider, put it that way. Moving on. So we also have other tools to our tool bag or services. So we also do area acquisition and sitting-based modelling. So we provide photogrammetry and LiDAR work with aerial photography and photo mapping to provide precinct models and sort of real-world conditions as well. And we've got some examples of that at our booth, which you can come and have a look. So before I finish off with another video and a little bit of Autodesk 360, which is how we also provide some of this information to our clients, just going over I guess the 4 key points we want to get across is that we can get involved and should be involved in all facets of the construction process. Certainly, if you are looking towards lean construction and ensuring there's no surprises, which is obviously everyone wants to do, having complete faith and trust in your spatial acquisition is the first point. And we can be involved in that, and certainly allowing you to have complete control and satisfaction that the quotes you're getting back in, that the people who are involved in the project, the models are getting produced, and in the manufacturing, and certainly in the case of ducting and expensive ducting, is going to fit and going to be right, because the space was correct to begin with. Construction, obviously, construction control and construction progress, so nothing wrong with scanning halfway through a job, or ideally per floor, making sure things are going along as supposed to be. Obviously implementation and rejuvenation. I'll finish off on two things, because I know we're really pushing for time. Certainly some of the newer tools, for instance the new Navisworks, or newer version of Navisworks. This is a MEP geometry extrusion or extraction process that we went through. Navisworks supports Point Cloud, has done for a while, and the recap system is now able to be embedded in things like Freedom files, which this one is, and could be. And the actual structure of that file is now set up in placeholder MEP components, which can be taken on by various people. A quick one, because just of its scale and size and in uniqueness, we were commissioned to go across to Papua New Guinea and scan the Papua New Guinea High Courthouse, which is nigh on 40 years, I guess, looking for a regen. That was completely interesting because, again, no documentation at all. And after 40 years of faithful service, it's had that many alterations and additions and extensions and, I won't say jerry-built, but infills between floors to create someone's office at some point. And so this is the way that the architects are engaging to try and figure out just what they're doing and what they can do. So a 3-level project, we were told, became 12 levels by the time we went in and found out all the sub-levels and side levels and levels on levels. So yeah, quite a large task. BIM 360, I'll say Autodesk 360. This is the tech preview version. Allows us to communicate these models live, mostly live, to our clients. So we've got, this is the extraction of the roof plant by Arups. And allows us to communicate that, and also pull up. So you can see like a head-up display here from the elements that you can see. So we've got elbow flange 150, 95. Very interesting use of this. Not quite like almost augmented reality, and certainly that's probably the next step, to combine that with a walk around the site and pull all this information back while and it understands where you're viewing. But some pretty interesting things there as well. And Mr. Alder might go through that in greater detail later on. And then, again, to keep to time, you'll also see that this model, the one we've actually hosted on Autodesk 360, again, is the complete one. The rendering side, the actual ability to display all these geometries. This model is only about 200 meg, so it's not crazy big. But again, it does a particularly good job of that. And communicating back to the actual client. So Dexus have been invited to this site, and they can spin around once they get their head around it, like I tried to do. It's the reverse, unfortunately, of all the Revit navigation tools. You zoom out to zoom in, and that's pretty handy. And the other one, which again doesn't quite apply to architecture, but the explode feature of, I guess everyone's worked on a construction job that would love to explode. In this case, you can. So we just grab that, move it around, and the whole thing comes apart into its Lego-like elements. So yeah, depending on how many breaks and facade breakups you've got, it's more impressive than others. But yeah, the ability to pull it apart, have a look at the elements inside, and then put it back together again is pretty good.